Okay, so the next thing you'll have on your exam is you're going to graph the solution set of the system, not of equations, but of inequalities. And along with your break-even points on my math lab, you should have some practice graphing the solution set of inequalities. Now, the nice thing about this problem is if you know how to graph lines, you can do this problem. The only additional information is, or additional problem solving is using a test point. Okay, so let's do an example. And let's see, I'm going to choose, okay, so 2x minus y is strictly less than 3. And let's see, x, let's say x plus y is, I don't know, greater than or equal to, let's just say 4. Okay, so this is a system of linear equalities. Remember, these guys are, right, these are boundary lines. So the first thing, maybe if you want to call it 1 or 2. Okay, so what we want to do first is the boundary line, right, is the actual equation. So the boundary line of 1 is 2x minus y equals 3. So we want to graph this line, and this is where you get to choose. Do you want to graph this line using the slope-intercept form, finding the intercepts? It doesn't matter, just choose your preference. What I'm going to do is I'm going to, let's see, I'll add, so I'm going to add y to both sides, because then my y is nice and positive. Again, this is just one suggestion. And I want my y isolated, so I'm going to subtract 3 from both sides, and I get 2x minus 3, right? That cancels, which is what we want. So, I mean, here's our slope-intercept form. If I just rewrite my y on the left-hand side, right, this is what I get. And there is my slope, right? So the slope is 2, right, or 2 over 1. Which means it's going to go up 2 to the right 1, right, or down 2 to the left 2. And our y-intercept, right, the point on the y-axis is always 0, comma, b. And, right, our b happens to be negative 3. Okay, so this is the information you're going to use to graph this line. So let's go ahead and graph it, and then I guess come back to the second one. So let's see. There is our Cartesian plane, x and y. Okay, 0, comma, negative 3. 1, 2, 3. Here is my intercept, and I'm going to go up 2. So 1, 2, and then I'm going to go over 1. Right, so rise over run. Right, you can keep doing the staircase, but I know that, let me just make this white. Again, this is not as a nice perfect line, pretend that's a straight line. Okay, so this is line 1. And actually, before I make a tiny mistake, I want you to notice this guy, this boundary, the boundary line is an equal sign, but this means not including a certain point. So when you see this strictly less than sign, right, this is not included. That's going to be a dashed line, right, as opposed to this guy, right, that's going to be a solid line. So my line should be a dashed line. So I'm just going to take my eraser since I already, where is my eraser? Okay, I'm having trouble. Let's see. Where did my eraser go? Ah, I don't want that. Okay, there it is. So, okay, I can see it, but it's not letting me. Okay, so this is supposed to be dashed, right? So pretend that white line is not there, right? That should be, right? It should look like that with arrows, right? Because it's a line that is going on to infinity. Okay, now we repeat the same thing, but before we do that, actually, we're gonna graph a line, shade it, graph another line, shade it, and see where the intersection of the shadings go. So how do I know if I should graph above the line or below the line? And this is where the nice little paint pail is useful on my math lab. Well, you can choose a test point, right? Any point will do. I'm gonna pick 0, 0. Why? Because the line is not on 0, 0. You can always choose 0, 0. Now, if I input 0, 0 into my inequality, so my inequality, right, is that guy right there. So 2x minus y is less than 3. So 2x minus y is less than 3. Let me just, so I can see everything. 2x minus y is less than 3. Okay, if I use the test point, so TP, if it's 0, 0, well, 2 times 0 minus 0, right, is that going to be less than 3? Well, that's 0 minus 0. Is 0 less than 3? Yes, it is. So this is a true statement. So if it's true, well, where was 0, 0? Well, it was on this side, right? It was above the line. I mean, if you picked 1, 1 or 1, 2, any of these red dots are all true statements. So that means that you are going to shade above the line. Now, if it was a false statement, then you would shade below the line. Okay, so let's do the same thing with the next equation, or inequality. And it looks like, right, here we have x plus y is greater than or equal to 4, and it's going to be a solid line because it's included. So x plus y is equal to 4. So this is 2x plus y is, let's just say, equal to 4. This is a nice slope-intercept form. Slope is, right, -1/1, and the y-intercept is 0, 4. So 0, comma 4, and let's see, -1. So I make this blue. So 0, 4 is right there, and my slope is -1/1. And if you want, again, you can rewrite this as 1/-1, right? You can put the negative in the denominator, meaning you're going to go up 1 and you're going to go to the left 1. So up 1 to the left 1. So up 1, whoops, up 1 to the left 1, right? Somewhere right there, and it's a solid line. So there is my, right, it's decreasing. And again, ignore the pink line. Should I shade, let me get the arrow, above the line, right? Should I shade all of this? Or should I shade below the line, meaning do the solutions exist here? And similarly, right, you can pick 0, 0. I'm going to pick a number other than 0, 0 just so you have, I mean, it doesn't have to be 0, 0. So I'm going to pick, let's see, maybe something, let's say right there. So that's above. So above the line. So I don't know, I'm just going to pick -1, comma -1, right? -1, comma -1 is right there. So let's move this and let's see, well, let me maybe write it here just so I have. So this is the test point. I'm testing -1, -1, and I'm plugging it into the inequality. So negative 1 plus a negative 1, is that greater than or equal to 4? Well, that's negative 2 is greater than or equal to 4. Okay, well, we know negative 2 is not equal to 4, but is negative 2 greater than 4? And in this case, it's not, right? This is a false statement, right? Negative 2 is less than 4. So since it was false, so let me get my blue. My negative 1 was right here. Okay, it's above the blue line, so that means that it's not true here. So it's 50-50. If it doesn't work here, it must work here. So then you shade your blue. And that's pretty much it. Your solution set, right? There's infinitely many solutions. It's all of these points, right? That point, that point, that point. I can just fill this. It's basically the red and the blue combined. So again, this is just graphing lines and using test points. Okay, I'm going to stop here because this is 11 minutes going already.